Giving me a pot, please help me. Bit on my tree and just I need you to set me free. Hot. Let's see. Let's see. All right. Let's see. Let's take attendance. I think. Oh, I can undock this. Look at that. Look what I learned. Whoop! What happened? Okay. Me. I can. Ooh, one person. Oh no, that person's gone. I scared one person away already. All right. Let's turn this off. And I want to talk about this real quick, the lab. I kind of wanted this to be an easy lab, so I'm sorry. I should talk about the labs a little more than what I do. It was just a bunch of print statements. That's it. So if you're confused or couldn't get it done, that's it. That's all it really was. You just run it. I grabbed Ariane's here. Did I say that right, Ariane? Yes. Yeah. Just by chance, that's just the one I stopped on. There's lots of others that did fine. Use the new line. That's clever. I like that. Use the new line. Kicks it down to the new line. Yep, no problem. So if you need to finish that up, that's fine. Next, let's take some more notes. So let's get out Chromebooks. Let's make a new Replit. I got to go here. New. There we go, finally. Java. How about let's date it, huh? I don't know if I dated it yesterday. 820 variable notes, something like that. We're doing variables today. Mercy, mercy. Create. The name will be up at the top if you aren't quite there yet. All right, we can probably get rid of hello world. No, I left it in there. It doesn't matter. That's not going to affect it. All right, here we go. Variable. Storage location for a specified type of value. So when we make variables, I'm not doing any new new documents today. We're just going to use this one. Variables hold values, and in Java, not only do you have to say what the variable name is, but you have to tell it what type it is. So one of the types that we have are integers. And to say an integer, you just do int for now. And maybe we do age and equals maybe 16. So your age is 16. Now it underlines it right away, and all it's saying right now is that we just haven't used it. We've made it, but we haven't used it. The value of the local variable is not used. That's fine. We just haven't printed out or multiplied it times 2 or anything like that. Other variables we have strings. So those are like words. So if it's not a number, it's a string. So your name maybe is Fred. Again, it's saying, hey, you've made this variable, you're not using it anywhere. So you're taking up memory that you probably don't need. But then when we use it later, it'll go away. We have Boolean. Boolean's true or false. So are you happy today? Yeah, we're in school. Of course we're happy. True. Notice that this one is, I'm colorblind. Is that blue? It's blue, right? So blue, that's still black, that's blue. This is called a primitive type. Primitive type, a string is a class. Notice how it's not blue like the others are. System, out, print line, and now we can print these. Print happy. We can use them. Notice that once I use it, that error is gone. It's like, oh, you are going to use this variable. Okay, my bad. It's all good now. And when we run it, it's just going to print hello world. And it's not printing the word true. It's printing really the value true, which there's a slight difference in those. That's not a word, it's a value of true. All right, some of the notes that we have. Identifier could be the name of a method. We saw methods yesterday, or the name of a variable. So a variable is what we call identifier in Java. They must, let me make a comment. They must start, I mentioned this yesterday, with a letter with the names of the methods. Cannot contain anything other than letters and numbers. So letters and numbers only. And if you have a space, that'll be an error. So no spaces. No spaces. Should I make that bigger? Can't see it. Or you're just looking for error. You can't see it or looking. You got an error already? Geez, we haven't hardly done anything. It could be you missed a capital. It could be you missed a semicolon. It's needle in a haystack. Oh, what's the error? No, it says it like over there. Like what's it pointing to? It's pointing to that print statement. Oh, it's print 1n, print ln. Okay. Your error. Oh, capitalized string. Anybody else? While we're at it? Okay. Capitalized string. You're welcome. All right. No spaces. So if you put, yeah, just can't have spaces in variables. Here's a little note. Pick identifiers that mean something. For example, and this is how we do identifiers when there's more than one word. You're like, well, if you have no spaces, all these words are just going to run together. So if you want shoe size, we'll go shoe and then capitalize the S. See that? So every time you see a new capital letter, that's the beginning of a new word in your identifier. And we try to keep variables lowercase to begin with. And then, because an uppercase usually signifies what we call a class. It's not that your program won't run, it's just organization. Case sensitive. So like we saw with string, I said, hey, you didn't capitalize S, and it's going to give you an error. Variables are case sensitive. So if I try to print shoe size, that'd be an error. If I made shoe size with the capital, tried it without later, it'll say, I don't know what this identifier is. All right, what else? Case sensitive, got that. No reserved words, like void, or you can't name your string string unless it's lowercase. Don't use main. Oh, speaking of that, this right here, that has to be main only because we're using replit. On any other program where you do Java, like I use Eclipse, no one else is waiting. I use Eclipse, you can name that one anything you want. You can't, you have to have main here. But we have to have main here only because Replit insists. It would not run if we named it anything else. All right, no reserved words. Primitive types. Primitive types are byte, short, int. Those are all integers. As far as math is concerned, those are all integers. And then byte, you have a very small window of what numbers you can use. Integers very wide. Long, that's a decimal value. Float is a decimal. Double is a decimal. Character is one character. And we talked about how Boolean is true or false. Notice what's not in that is in that list is strings. Strings is a class. It's not a primitive type. And we'll keep this in so it's the same. I just wanted to tell myself hand out chart. So I just want to keep that line in there so the notes are the same. Hope you can read that. I think I made it big enough. Three, 4, 2, 3. I was gonna lick my fingers to do this. It doesn't work anymore. It's blocked. 2, 3, 4. Can you hand those over for me, please? 3, 4, 5, 6. You're welcome. Do I have this up here? No, this, oh, yeah, there we go. No, this is class information. Yeah, take it easy on that. Where is it? This was day 1. Here's day 2. Is it here? Yeah. Trying to bring this chart up. All right, so a byte is a very narrow window of numbers. So a byte, you can only store -128 to 127. And its memory usage is 8 bits. Believe it or not, you have to know those. You got to know that middle column. Go ahead. Oh, I didn't give you enough. Okay. Sorry about that, guys. There you go. There you go. A short, -32,000-ish to 32,000-ish. Then the integers really starts to widen out. I'm sure there are times if you're an astronomer, you're going to want to use more than -2 billion to 2 billion, but we figured that that range will cover pretty much anything you ever would want to do. So we usually use integer values. Long, float, double, those are all decimal values. Notice that a byte is 8 bits of memory. This is called memory. 16 bits, 32 bits. So long is 64 because now you're getting into decimal values. 32, 64. Characters 16-bit, whatever unassigned is. And then Boolean is just 1 bit because it's either true or false. So there's not too many choices there. So it uses very little memory at all. You have to know those. Do you hear me say that? That'll be test questions. It just takes a little bit of effort to memorize them. There's not 100 up there. There's only, 8 or 9? 1, 2, 3, 4, 5, 6, 7, 8. So you gotta memorize 8 things. Know that. All right, Let's go back to programming. Handout chart did that. Where's say? There it is. Oh, let's turn it on the other side. And we have ASCII values for all these characters. So now we're kind of looking at characters. There it is. Oh, this is not going to show up very well. But the computer turns what we type in. Let's see, decimal, here's the characters. Let's see, we want to know what A is. A is ASCII value 65. Here's what it turns it into. This is the machine language right there. Ones and zeros, on and off. One is on, zero's off. So we know it as 65. There's 65 in binary. You've heard that there's 10 people in the world, right? Those that know binary and those that don't. Thank you. 10 is 2 in binary. So this one, A, there's 97. If you know 65 and 97, if I ask you what is the ASCII decimal for H, you can start at 65 and work your way down. So what our curriculum asks you to do, I went there, is ASCII values you must know to get the others. Here's what you might be tested on. A is 65, capital A is 65. Lowercase a is 97. And 0 is 48. So those three. And we figure if we ask, well, what is the ASCII value for the letter L? You can start at A and work your way to L. Capital or, capital. If we say, what's the ASCII value for the number 7? You should just say, well, it's 55. It's 7 after 48. All right, some more programming now. So we know pay attention to capitals and lowercase and all that. It's got to be exactly. So int, how about let's look at the maximum value of an integer is built into Java. If you want to know what the maximum value is, you capitalize integer. Notice that's capitalized. Dot. And if you have help turned on, does anyone not have this right here when you hit that dot? That box come up. Everybody has that box coming up? Well, now what you could do is you can just go max value, or you can just type it in. You can just type it in too. And then we go system, print line, max value. And it'll show you, now remember it was on that chart, it just kind of says 2 billion. Well, it'll give you the actual number now. Eventually. There it is. So 2,147,483,647. Now here's kind of a cool thing. System out, print, line. Let's go max value plus 1. Anybody know what this does? No, but good guess. I like that guess. You would think it would give you an error. Wait till you see this. I mean, it's not like Counter-Strike's going to pop up, but it wraps around to the lowest value. Isn't that weird? I don't know why they built it that way, but that's what they did. So there's your lowest value for an integer. Int cannot store decimal values. I mean, because it has to store integers. If you want to store an integer, then we usually use double. That's what we usually use, is double for decimal values. Oh, how about some other things? How about long? We can even do max long is equal to, you just got to capitalize long dot, and then you could see the max value, you could see the minimum value if you want. How about max value? Maybe we print it out so we actually see it. And you can see that long is the beginning of decimal values, and it has a much, much bigger maximum value. I mean, it's massive, right? How about characters? How about we just call the variable letter equals A? System out, print line. Let's print the letter. And it prints out A. But what the variable is really holding is a number. It's really holding a number for A. By the way, since we've already instantiated what they call instantiating letter, if you do character letter again, it'll give you an error. It'll say duplicate local variable letter. So if I want to change the value of letter, I don't say it's a character. We've already established that. You can only establish that one time. How about equals, what number did I pick? 34. Now let's print letter. And what you can do is copy paste, since I'm printing letter again. So when it's character A, it prints A. What will it print when I say it's 34? It prints a quotation mark, because that's the ASCII value for a quotation mark, is 34. Now, of course, you wouldn't want to, I mean, I don't know why you would want to use that. I don't know if you want to go look up the ASCII value for all these characters and then assign that. You can just, the program is built so that if you just type this, it'll just know to type A. We don't have to do that, but it's available to us. Let me put it that way. How about this? System out, print line B. And it prints a B. But if we do this, how about copy paste +1? Now you're telling Java, turn this into its ASCII value and add 1 to it. So now it prints 67, because the ASCII value for B is 65, capital B. 66, excuse me. Adds 1, prints out 67. Maybe we should make a note of that. So if you're looking at the notes, prints 67. How about do this? Prints B. I should probably do that more and say, rather than just giving you this code saying what it actually does if it's fairly short. How about double? Double num is equal to, now we can start putting in decimals. How about 120.7? And we go system.out.println num. And does 120.7. We just print it out. Or multiply it by 2. How about we do that? times 2. You know, you can do a little bit of math with it also. It doesn't have to just be print out the number. So it'll double it. This is interesting. You definitely have to know. Let's say we do num is equal to 125, 125. And then we print out num. Now, if you're kind of drifting off, I get it. You know, some of this is not the most exciting thing you ever done in your entire life. If you're drifting off, make sure you listen to me right now, because this might cost you a point on a test that's rather frustrating. Notice that when we say that num's a double, and then we put just 125 in and we print it, it prints out 125.0. So they'll say, you know, double on a test, double num equals 127. When you print it out, num, letter A might say 127, letter B might say 127.0, C might say 12, I don't know what the others would be. But if you pick that, that's wrong. This is the right one right there. That's the correct one. So you gotta, when you pick your answers on the test, you have to pay attention to whether that was an integer value or a double. That'll tell you which one, because if that said integer num, well then letter A is the right answer. If it's a decimal variable, it'll print out 127.0. You guys see what I'm saying? Any questions? All right. We don't have a whole lot left. So hang in there. Hang in there. How about a float is a little weird. I don't know exactly why you have to do this. And someone asked me about this on a Replit that they were doing, or you know, maybe working ahead a little bit on some of the labs, and it was given an error for float. To make a float, it's you use ice cream and usually root beer. Oh, I love root beer floats, I'm telling you. Every time I type float on here, I get hungry. 2533, but you need an F after that. Don't know why. If it's a float, you have to put that F there, or else you're going to get an error. It's just saying I'm not using it. Let's take it off. If we try to print it now, because it's not giving us an error. Num2. That'll be a runtime error. It said possible lossly conversion from double to float. So it thinks this is a double, and it thinks you're trying to convert it to a float. Well, we're going to tell Java, no, this is actually a float. And now when we run it, it's fine. There we go. Finally, last thing we'll do, I'll try to get this to the top. Cast a number. If we do system.out.println, and we want to say, well, we're going to do this, but I want it to be a character. Remember we did this earlier, the B and then plus 1, and it gave us a number. So I think it gave us the 67. So that 67 right there is what this should print without this. But with the parentheses, the 2 sets of parentheses by them, it's saying, go ahead and calculate this. I know this is going to be a number, but then cast it as a character instead of a number. So it won't print out 67 now. It should print out the letter C, 1 past B. We're casting that number as a letter now. Let's see another example of this. How about double? We're going to cast this as a double. Now the number 34 is an integer. Do I have too many parentheses? I think I do. 34 is an integer. It's not a double. It doesn't have a decimal. But we're saying turn that 34, turn that integer into a double. So when it runs, it should print 34.0, not just 34. So we turn that into a double. And the last thing we're going to do here integer 34.5. We're going to say turn that double, turn that into an integer. I think it's just going to be 34. I think it truncates rather than rounds. I think it just grabs the integer part if I remember right. Yeah. So that'll be 34. So you can convert one type into another type, and it's called casting into a different type. What time we get out of here? Is that right? 10:17? Oh no, 11:11. This is third period. No, this is second period, right? Second period. Okay, we got plenty of time. Let's do a Kahoot, just for fun. Log in. What is this? Update school information. Oh, okay. That's gone. Become an expert? No. How do I get out of this? I mean, yeah. Oh, continue for free. Yeah. What? I already have all. Okay. Type your country. There we go. Oh, Mr. Ortmeyer is calling me. I'm going to take this really quick. Hello? I'm not, but go ahead. I have them, yes. Yeah, I got them, and I'll be all set for tonight. Yep. Okay. I was up there over the summer, and it seemed to be fine. You know, I mean, we used sound for graduation, a little bit of sound for graduation. So it was working then, and I'll go up there early today and make sure everything's running. All right, you bet. All right, bye. Elkhorn North has their scrimmage today. All right. Inner school, I already did this. My apologies. I didn't think it was going to do this to me. I don't know how to skip it. You can put your phone away. You'll live without it. You'll live without it. Put it away. All right, what do I want? Syntax output day one. See all. Arrays, abstract. Oh, I have a lot of stuff. Math, syntax, and variable quiz. Here we go. Let's try this one. Teach. Classic. Ready to join. What does that mean? Oh, it's just slow. There you go. There's your code. I think that's all. Start. Brace. They must have braces, open and closed braces. What was brackets? That's probably a terminology thing. Brackets, braces. They need those right there. So if you missed it, probably a terminology thing more than anything else. Jack's in the lead. Good job, Jack. What is output by the code below? Run /TAB. It will not, that T is part of the escape sequence, so it will not print that T. That T is a command now. It says space over or tab over AB. So that's probably the tricky one. That's really probably a common miss one right there. So it will not print the T because that's an escape sequence. All right. Ariane in the lead. Was the output by the code below? Very good. There's no escape sequence there. It's just going to print attic. That's it. Oh, he's holding the lead, holding steady. I know it's kind of hard to see back there. I apologize. It's kind of small. Yeah, there's an escape sequence here with a single quote. Escape sequence, a single quote. So it'll type a single quote and then apples. So the answer is B. Answer B. Uh-oh. Marv in the lead. Is the question on your screen? Oh, that's so tiny. My apologies. Oh, look at the distribution there. And maybe you just couldn't see it. You have 6. That's a number, but all of a sudden you get this character. Now it's a string, even though there's really nothing that is being output by that string. It is a string now. Now remember, it goes order of operations. So it'll do this plus, so it'll take 6 and add a tab, then it'll add 3. But now we're adding to a string, which doesn't add numerically, it adds by character. So it adds a 3, adds a 5, so it's letter A. Yeah, A's the answer on that one. Good thing we're going over this. That was a tricky one, and maybe you just couldn't see it in the back. Good. Yep. That is just 2 numbers. It's just 2 integers. There's a plus in between. It will actually add those 2 together because nothing in there is suggesting that it's a string. So that one's 14. Marv holding steady. Yeah, notice there's not a print line there. There's only a print statement there. So that keeps it on the same line. So that will not kick it down. If that was reversed, if it was line on top and print on the bottom, then it would be letter B. But that print keeps it there. So it's actually letter A. The space is right there. So that's why there's a space in between. Tricky one. Any questions on that? These are these are very similar to what you'll see on your test. Marv, dominating. Kind of gave that one away, didn't I? We had 27 sign up, so I don't know why one person is not playing along. This one will kick down to the next line, so it's letter B. B's the answer for that, because the line is first, so it kicks it down. Luke's catching up. Seven plus 4 plus space plus 5. 7 plus 4 plus space plus 5. Think order of operations. Very good. Very good for 20 of you. All right. This will be 11 because it'll add it. It hasn't encountered a string yet. Works its way across. 11, then it hits a space, then it hits plus 5, so it'll add 5 to that space. So C, letter C. It's not 7-4 because it does order of operations and it hasn't hit a character yet. So that's just going to actually add those two together. Good thing we're doing this. I would hate to see you miss those on the test. If you have questions on that, let me know. I'll try to explain it best I can. Character let equals 68. You haven't probably memorized this yet. Do the best you can. You can look at your notes if you want. Probably did this one a little early. Yep. Int num equals 5, num equals 6.7, print let. So what will it print if it goes 5 and then 6.7? Will that a syntax error, a runtime error? Will it print 5? Will it print 6.7? So this instantiates it as 5, but this will change it to 6.7. So when it prints, it'll print 6.7. Nothing wrong with, I know it's all underlined, but that's nothing. Maybe that's what threw you off. Congrats, 6,000. Oh, yeah, third. Second, Dan. First. Very dramatic. Marv got it. Good job, Marv. Got a lot of things to hand out to you. Let's go with the notes that we did. 2. Can you pass those down for me, please? 2, 4, 2, 3, 4, 6, 2, 3, 4, 5, 2. Yeah. Is that a good thing or a bad thing? You like that? Yeah. All right, I forgot to hand you the worksheet yesterday, but I do have a place for it on Google Classroom. So technically these are all late, but that's my problem, my fault. I don't know what Google Classroom does if you turn stuff in late. For this one, you can ignore it. This is what I should have handed to you yesterday. Now, if you printed it out and you did it, awesome, love it. But I apologize for we left and I just never gave it to you. You're welcome. 3, 4, 6. There we go. 2, 3, 4, 5. 6. And then I got the one for today. And I would have just said, well, I'm not going to give this to him because I forgot. But dang it, I really want you to practice that because that's going to be your test question. So we can't skip it. My apologies for not giving it to you before you left. So here's today's. Here's the variable stuff. I also have the answers to these on the website. You know, I don't want you to just go in and copy it. Of course, that's not going to help you on the test. But I want you to be able to check your answers also. Six, there we go. I know you're digging in, and I love it, and I know you're doing this now. But hey, take a look. Here was yesterday. You got the ASCII box and the worksheet, the output worksheet. Today we have the worksheet that I just gave you, and there is a lab. I don't know if there's anything I can really mention for this. Here's the sheet that I'll put up on. I already have it on Replit, but you're going to create this output, and just by doing a lot of print statements. So read through that. If you have questions, shoot me an email. Hopefully I'll get back to you in a timely manner. Oh, there it is, teacher. I don't quite need it this big. Assignment, is it just, hopefully it's just the next one. Yeah, variables, here it is, variables, right there. Looks like someone's already done it. All right. Luke and Dan, did you just not know you're supposed to be doing this?
I didn't know that. I don't see anything.
There's a submit at the top right. It looks like it's grayed out, but it's not. You can click it. Did you sign up for the class?
Yeah. You click on students.
Student, go here. Students. And I wasn't showing you this to yell at you. I was just making sure you knew how to do it since we're at the beginning of the year here. Okay. Everything good? Yeah. Look, do you see this submit? Okay. It's all right. Oh, no. You're not in the class. Hey, here, do this. Highlight all that and copy. Since you already did it, let's use it. All right, now click on your name. Click on it should arrow down. It should have given you a list when you click on your name. Click on your name again. Yeah, go to student. There you go. And then pick the class. I should have shown you this, guys. This is my fault. My fault.
I just didn't know what to do. Oh, okay.
There it is. And now, I don't know why it's all, there we go. Highlight it.
Delete all that.
No, just hit paste now. Control V. There you go. And hit submit over on the right.
Okay.
There you go. You're welcome. This, all right, so let me write on the board, okay? That it, something like that. Here's the first escape sequence. And so it looks for the next character. So here's the next character and it prints a backslash. That's done now. It's gone. It's gone. We did it. Now it prints a T, gone. Hits a escape sequence, sees the next character, does that. That's done now. And then hits Sam. Make sense? All right. Good question. That's a tricky one. Why is it dying? You got your charger? Oh, here. Okay. Where's that at? Here it is. There you go. Yep. I think that's already plugged in. Oh, it does?
Yeah.
Is this your own?
Yeah.
Oh, okay. All right. Oh, it's new. All right. Grab your charger and I'll plug it in for you. You're welcome. I'm going to throw it down and come around. Oh, you dropped it. Uh-huh. Yes.
So wait, you know, you find it not like the mask amount for that, right? For that. Right.
What's that now?
So this you have to define on each.
That's kind of the purpose, I guess, to use those. Yeah. Yeah. Oh, is that what it's saying? Let me see. Do I have the output on that lab or not? Let me take a look. Hold on, Ashton. I'll get back to you on that. So here, maybe I didn't put what I need to put on here. Here's the variables. Oh, I have to do something else. I have to act like I'm editing it. Oh, here's the lab sheet right there. That's also on my website. Right. Yeah, here's the lab sheet right here. Ashton, can you hear me? Yeah, okay. Go ahead and unmic your, if you, can you unmute your mic? And I'm the only one that can hear you.
Yeah.
Okay, yeah, it's in my little earpiece. I'm the only one that can hear you right now. Do you see on the screen this, my first semester here?
Yeah.
So the worksheets, like yesterday's worksheet is right here.
Oh, okay.
And if you can print that out and submit it into Google Classroom, that's kind of the ideal thing. Now, if you don't have the ability to print stuff out, then just do it on like lined paper.
Okay.
See what I'm saying?
Yeah.
Okay. And then there's another worksheet today. So this link is in that class information. Can you get to this?
Let me see.
Okay. We're doing Pledge Allegiance right now. States of America and to the republic for which it stands, one nation, under God, indivisible, with liberty and justice for all.
I'm in the class information like slides.
Yeah.
Where is it from there?
Oh, you know what? I put it in Google Classroom.
Class schedule?
Yes, class schedule. That's right.
Oh, yeah. I found it.
Okay. And you can probably see me on the screen. See this headset right here?
Yeah.
This is where your voice is coming from. So I'm the only one that can hear you.
Okay.
Yep. So if you ever have any questions during class, I don't mind if you ask. I'll be the only one that hears you.
Okay, I found the worksheets.
Okay. And then so for the first few days here, if you see some zeros and you're like, hey, where are these coming from? Just shoot me an email. And if I see that you're missing stuff, I'll probably shoot you an email and say, hey, is this because you didn't do it, or is it because you didn't know to do it? And so just keep the lines of communication open, and I'll work with you. I have no problem with that.
Okay.
All right, yeah, go ahead. I think it's that float. Remember the float needs an F? No, because that's a comment. Let's see what the error is. One error on line 29. All right, let's see what line 29 is saying. Reach into file. Oh, without parsing, that means in the lab setup, I must be missing a brace. Yeah, there's none at the end. We need 2 at the end. On the lab, you need 2 braces at the end. Here we go. Yes, right. Pretty much, yes. Yep. Mm-hmm. Yeah. Yeah. Okay. Okay.
folder for RPC.
Perfect.
And save.
Okay.
Then go to file. That's it. When I go to search for it, it's 2.1. I can't find it anywhere.
Go get your Chromebook. Let's see if we can do it from there.
Do you want us to turn this also like two classes?
Yes. Yes. Yep. Go to your Google Drive. You guys done with everything? 10:17, right? Isn't it? What is today? Thursday? Yeah, 10:17. Yeah, we got a lot of time left. What's that now? Oh, okay. That's fine. That's fine. I'm not yelling at you. Just I figured you probably thought we were leaving. There we go. Oh, so you have nothing in there. It doesn't. Yeah. Get your phone out again. Let's see. Let's try one more time.
I don't know if it's needing a Wi-Fi or. So I took it off Wi-Fi. Oh, but it's go, but now it's back on.
Okay.
But we'll try it too. Let's go here.
What's up? Okay. RPC. Save. Save. Here's another way to do it, because clearly that's not working. Try to email it to yourself, and then you can use your Chromebook.
I did try to do that and it kept giving me failed. So I can try it one more time. I did try to email myself. To data, right? Give it a sense. Oh, actually,
Okay, I guess you figured it out now.
I can't go on school Wi-Fi to do it.
Apparently.
Okay.
I don't know why that is, Jack. I don't know.
So then
Now you should be able to just.
I think from now on I'll just turn it in at home and not at school.
Okay, sounds good.
So I can be at home Wi-Fi.
Right, I hear you. There you go.
Sorry that it was.
No, that's all right. Glad I could help you.
I don't know what time it was supposed to be turned in.
That's okay. Don't worry about it. These first few days, we're just trying to figure all this out. I'm not going to give you any late.
So now that it's there.
Yeah, you should be able to.
Okay. So for looking at this one.
Okay.
A couple questions for this one. Did you print double D so you get 9.9? I got that part. And you can do D in 5.2. So does it matter if you have the double or do you need the double?
No, you don't. You can't have the double twice.
Oh,
Because once you instantiate this variable, you can't instantiate it again. You can change it like it's doing here, but you can't instantiate it twice.
give an error if you do
You'll
it
get
again.
an error if you do it again. That's right.
And then also,
Huh?
I didn't get why these were different.
All right, I got to go through the whole thing here. Let's see. S. Oh, there's S. It's a short. And what's C? C is a 97. Short S equals 3. Where's C? Oh, C is a character. You can't put a character into a number. That's what we're doing. We're saying this. Oh wait,
So S would be.
what's S?
That's S.
S is a number.
Yeah.
You can't put a character into a number.
Okay. I got
That's
that.
why. Yep.
And it's the same thing as the last one, I guess.
Probably. Let's see. What's Z?
I don't know.
Integer.
Okay.
Z's an integer.
And W is.
W is, we got to see where it's instantiated. A double. You can't put a double into an integer. You can't do that.
Okay.
Okay. Mhm.
So throwing an error because it's trying when I put input my long. So is there a format code for long? Like there was for float?
I don't think so. Gruesome, baggy nature. Seems to be fine. There's something else there then.
Yeah.
What's the error say? Incompatible types. Possible lossy conversion. Is the number too big?
It shouldn't be because it's always 2 to the power of number because it has -1.
Yeah. Make the number smaller. Take off the E18 and see if we still get that error. Long one. Oh, long's a, just go 9.2. We're just trying to eliminate possibilities here. You gotta be kidding me. Long's not an integer, is it? Oh, no, long's a decimal, right? No, long's an integer. Yeah, long's an integer. Yep. Ugh. Number 12.
17.0. Is it just because that's only a point I was running for number?
Long is a decimal, or long's an integer value.
And then this is not.
Double is a decimal value. That's right. Okay. Yes, that's right. Okay. What's the error say? Semicolon expected. Do you have a semicolon after it? Yeah, okay. You have the quotation marks in it. Good. Did you create the short one variable? See, you haven't created that variable, so it doesn't know. Yeah, all you have is byte one, so it'll know byte one, but it won't know what short one is. So you got to go up here and create it, instantiate it. You know what I mean? All right. Ugh. This year's all right. Gonna unplug you. You're welcome. See you, Ashton. Take care, buddy.